Chapter 2. Quadratic equations. The equation of the form ax square plus bx plus c is equal to 0 where a, b, c are the real numbers and a is not equal to 0 is called quadratic equation in variable x. And therefore, the general or standard form of quadratic equation is ax square plus bx plus c is equal to 0. The highest index of variable is 2 and so it is a second degree equation in one variable. Now some equations are given here and we are going to find out whether they are quadratic equations or not. So the first equation is 5x square is equal to 36. Here we'll compare the given equation with general form of the quadratic equation. So a is equal to 5, b is equal to 0, c is equal to minus 36. All these are real numbers and a is not equal to 0 and therefore it is a quadratic equation in variable x. Now look at this equation. X square plus 5x plus 6 is equal to 0. Here a is 1, b is 5, c is 6. All are real numbers. Also a is not equal to 0. So it is also the quadratic equation in variable x. Now the next one is 5m cube minus 4m plus 7 is equal to 0. Here the maximum index of the variable m is 3 and so it is not the quadratic equation. Next one, 5z minus 7 is equal to 0. That means 0z square plus 5z minus 7 is equal to 0. But here a is equal to 0, so it is not the quadratic equation. Now next one, x minus 5 upon x is equal to 3x minus 9. By observation, it does not seem to be quadratic, so now we'll write it in the standard form. Multiplying both the sides by x, we get x square minus 5 is equal to 3x square minus 9x. That means 3x square minus x square minus 9x plus 5 is equal to 0. That means 2x square minus 9x plus 5 is equal to 0. Here a is equal to 2, b is equal to minus 9 and c is equal to 5, which are real numbers. Also a is not equal to 0 and the maximum index of the variable is 2. So the given equation is quadratic. Now next one, write the following quadratic equation in the standard form. Ax square plus bx plus c is equal to 0. Y square minus 9 is equal to 13y. Therefore, y square minus 13y minus 9 is equal to 0. Now we'll find out the roots of the quadratic equation. The values of the variable which satisfy the given quadratic equation are the roots of the quadratic equation. So the question is, if one root of the quadratic equation x square minus 7x plus k is equal to 0 is 4, then find the value of k. Here x is equal to 4 is the root of the given equation. That means it satisfies the given equation. Therefore, 4 square minus 7 into 4 plus k is equal to 0. Therefore, 16 minus 28 plus k is equal to 0. Therefore, minus 12 plus k is equal to 0. Therefore, k is equal to 12. Now we'll use the different methods of solving quadratic equation. The first is factorization method. Now the question is, Solve the following quadratic equation by factorization method. X square minus 17x plus 60 is equal to 0. Now first we'll multiply 1 into 60, the product is plus 60. If the product is having positive sign, there are two options. Both the factors should be positive or both should be negative. To confirm this, we have to look at the sign of the middle term. Here it is negative, and therefore both the factors should have negative sign. So by splitting the middle term, we get x square minus 12x minus 5x plus 60 is equal to 0. Therefore, x into x minus 12 minus 5 into x minus 12 is equal to 0. Therefore, x minus 12 into x minus 5 is equal to 0. Therefore, x minus 12 is equal to 0 or x minus 5 is equal to 0. Therefore, x is equal to 12 or x is equal to 5. Next one, x square minus x minus 132 is equal to 0. Here, the product of 1 and minus 132 is minus 132. As the sign is minus, one factor should be positive and one should be negative. The required factors are 12 and 11. Now, look at the sign of the middle term. It is negative, and therefore the greater factor should be given the negative sign. So the factors are minus 12 and plus 11. So by splitting the middle term, we get x square minus 12x plus 11x minus 132 is equal to 0. Therefore, x into x minus 12 plus 11 into x minus 12 is equal to 0. So x minus 12 into x plus 11 is 0. Therefore, x minus 12 is equal to 0 or x plus 11 is equal to 0. Therefore, x is equal to 12 or x is equal to minus 11. Now the next one, m square minus 84 is equal to 0. Therefore, m square is equal to 84. By taking the square root of both the sides, m is equal to plus or minus 84. So m is equal to plus or minus under root 12 into 7, that is equal to plus or minus under root 4 into 3 into 7. Therefore, m is equal to plus or minus 2 under root 21. And therefore, m is equal to 2 root 21 or m is equal to minus 2 root 21. Now the next method is completing square method. We can complete the square by finding the third term by formula, that is equal to 1 upon 2 into coefficient of x bracket square. Now solve the given quadratic equation by completing square. 4p square plus 7 is equal to 12p. Therefore, 4p square minus 12p is equal to minus 7. First we'll make the coefficient of the first term 1, and therefore we should divide the each term by 4. So therefore p square minus 3p is equal to minus 7 upon 4. To find the third term, that is equal to 1 upon 2 into coefficient of p bracket square, that is equal to 1 upon 2 into minus 3 bracket square, that is equal to 9 upon 4. And therefore, the equation is p square minus 3p plus 9 upon 4 is equal to minus 7 upon 4 plus 9 upon 4. To the left hand side, square root of p is p, the sign of the middle term is written minus, and the square root of the third term is 3 upon 2. So p minus 3 upon 2, the bracket square, is equal to 2 upon 4. Therefore, p minus 3 upon 2 bracket square is equal to 1 upon 2. Taking square root of both the sides, p minus 3 upon 2 is equal to plus or minus under root 1 upon 2. Therefore, P is equal to 3 upon 2 plus or minus under root 1 upon 2. That is equal to 3 upon 2 plus 1 upon root 2 or 3 upon 2 minus 1 upon root 2. Now we'll make the denominator same, that is 2. So P is equal to 3 upon 2 plus root 2 upon 2 or 3 upon 2 minus root 2 upon 2. Therefore, P is equal to 3 plus root 2 upon 2 or 3 minus root 2 upon 2. Now the next method is formula method. Alpha and beta are the roots of the quadratic equation and they are denoted by alpha is equal to minus b plus root b square minus 4ac upon 2a and beta is equal to minus b minus under root b square minus 4ac upon 2a. Here x is equal to minus b plus or minus under root b square minus 4ac upon 2a is called as quadratic formula. So the question is, using formula method, solve the given quadratic equation 2x square minus x minus 4 is equal to 0. Comparing with ax square plus bx plus c is equal to 0, we get a is equal to 2, b is equal to minus 1 and c is equal to minus 4. Therefore, x is equal to minus b plus or minus root b square minus 4ac upon 2a, that is equal to minus into bracket minus 1 plus or minus under root minus 1 square minus 4 into 2 into minus 4 upon 2 into 2. That is equal to 1 plus or minus root 1 plus 32 upon 4. That is equal to 1 plus or minus root 33 upon 4. So, 1 plus root 33 upon 4 and 1 minus root 33 upon 4 are the roots of the given equation. Here, b square minus 4ac is called as discriminant of the quadratic equation and its value is denoted by delta. If delta is greater than or equal to 0, then there are real roots. These real roots may be equal roots if delta is equal to 0 and they are unequal roots if delta is greater than 0. Now we'll see the relation between the roots and the coefficients. Here alpha and beta are the roots of the quadratic equation ax square plus bx plus c is equal to 0. So the sum of the roots, that is equal to alpha plus beta, is equal to minus b upon a. That is minus coefficient of x upon coefficient of x square. And the product of the roots, that is alpha into beta, is equal to c upon a, that is equal to constant term upon coefficient of x square. So now the question is, if one root of the quadratic equation kx square minus 5x plus 2 is equal to 0 is 4 times the other, then find k. Kx square minus 5x plus 2 is equal to 0. Here a is equal to k, b is equal to minus 5 and c is equal to 2. Now alpha is equal to 4 into beta and alpha plus beta is equal to minus b upon a. Therefore, 4 beta plus beta is equal to 5 upon k. Therefore, 5 beta is equal to 5 upon k. Therefore, beta is equal to 1 upon k. Therefore, k is equal to 1 upon beta. Now, alpha into beta is equal to c upon a, that is equal to 2 upon k. Therefore, by substituting the value of beta, we get alpha into 1 upon k is equal to 2 upon k. Therefore, alpha is equal to 2. Now, alpha is equal to 4 beta. Therefore, alpha upon beta is equal to 4. Therefore, 2 upon beta is equal to 4. Therefore, beta is equal to 2 upon 4, that is equal to 1 upon 2. But k is equal to 1 upon beta, therefore k is equal to 1 upon 1 upon 2, that is equal to 2. Therefore k is equal to 2. Now next is, if the equation is not in the quadratic form, we can reduce it to quadratic form, and for solving we can use the relation x square plus 1 upon x square is equal to x plus 1 upon x the whole square minus 2, and x square plus 1 upon x square is equal to x minus 1 upon x bracket square plus 2. Now solve the equation x square plus 2x in one bracket into x square plus 2x minus 11 in another bracket plus 24 is equal to 0. In the first and second bracket, x square plus 2x is the common term. So let x square plus 2x is equal to y. Therefore, y into bracket y minus 11 plus 24 is equal to 0. Therefore, y square minus 11y plus 24 is equal to 0. Now by splitting the middle term, we get the factors of plus 24 are minus 8 and minus 3. So y square minus 8y minus 3y plus 24 is equal to 0. Therefore, y into bracket y minus 8 minus 3 into bracket y minus 8 is equal to 0. So y minus 8 into y minus 3 is equal to 0. So y is equal to 8 or y is equal to 3. Now substituting the values, we get x square plus 2x is equal to 8. Therefore, x square plus 2x minus 8 is equal to 0. Now splitting the middle term, x square plus 4x minus 2x minus 8 is equal to 0. Therefore, x plus 4 into x minus 2 is equal to 0. Therefore, x is equal to minus 4 or x is equal to 2. Now for the another value, x square plus 2x is equal to 3. Therefore, x square plus 2x minus 3 is equal to 0. Therefore, x square plus 3x minus x minus 3 is equal to 0. Therefore, x plus 3 into x minus 1 is equal to 0. Therefore, x is equal to minus 3 or x is equal to 1. Therefore, x is equal to minus 4, x is equal to 2, x is equal to minus 3 and x is equal to minus 1. Next question. The sum of a natural number and its reciprocal is 10 upon 3. So find the number. Let the natural number be x and therefore its reciprocal is 1 upon x. Therefore, x plus 1 upon x is equal to 10 upon 3. Therefore, x square plus 1 upon x is equal to 10 upon 3. By cross multiplication, 3 into x square plus 1 is equal to 10x. Therefore, 3x square plus 3 is equal to 10x. Therefore, 3x square minus 10x plus 3 is equal to 0. Now 3 into 3 is 9. So by splitting the middle term, we get the factors minus 9 minus 1. Therefore, 3x square minus 9x minus 1x plus 3 is equal to 0. Therefore, 3x into bracket x minus 3 minus 1 into bracket x minus 3 is equal to 0. Therefore, x minus 3 into 3x minus 1 is equal to 0. Therefore, x is equal to 3 or x is equal to 1 upon 3. But x is a natural number and therefore x cannot be 1 upon 3 and therefore x is equal to 3 is the natural number.